Okay, we're only going to be doing one topic again today, but this one topic has kind of a lot of little parts to it, and honestly, a lot of these topics will end up overlapping. So that's kind of why, like today, I'm only going to cover one topic again because it's important that you understand the parts of this topic because it will be repeated in other things, even if it goes by a different name. So that's the beginning of this unit. We're taking it pretty slow because it's going to be used a lot. And it's probably going to take you a minute or two to write this down because there's a lot of writing in this unit, or this section, I guess, today. So we're going to be talking about relative extrema. They sometimes go by the name local extrema. And the word extrema itself kind of makes it feel like it's a lot more than it is. But extrema is just kind of a single word that refers to maximums and minimums at the same time. So if you are asked to find extrema, you are going to be asked to find any maximums or minimums. And I know you guys, you know what maximums and minimums are. In pre-calc, if I remember correctly, a majority of the time when you guys were asked to find a maximum or minimum, you did it on the calculator for the most part. And you were probably only asked to find what's actually going to be called eventually here. You would have been asked to find an absolute max or an absolute min. So like if you think of a normal parabola, like x squared, this would have an absolute minimum because it's the very bottom of the graph. What we're going to be focusing on is slightly different. Because we start working with graphs and functions that are a lot more complicated, they actually have multiple locations that have the top of a hill or the bottom of a valley. And those are going to be called relative maxes and relative mins. Now the actual definition, oh, that was close. I almost picked up a real pencil to start writing on my tablet. The actual definition, like say for a relative max, is whenever your function changes from increasing to decreasing, that's going to be known as a relative max. So in my head, I think of that as the top of a hill. And a relative min is whenever your function changes from decreasing to increasing. Who was our expert again? Ari? Yeah, Ari, I think you were the expert, right? It comes up a lot. But the upside to this is you will 100% know exactly what critical numbers stand for. Do you remember why this is called a critical number at the top or bottom? Good. Good. I don't know if that was off the top of your head or you looked it up, but either way, that was good. Okay, so what we're going to find is critical numbers and critical points basically happen whenever you change from increasing to decreasing. So this is kind of how it's going to tie in together with what we did yesterday. Today we're going to be focused on figuring out when our function is increasing, which means positive slopes, and where our function is decreasing, which means negative slopes. And we are going to use the fact that critical numbers are exactly where you change from positive to negative slopes. And there's definitely, loopholes and details in there, but this is where 99% of everything happens. Does anybody need me to keep this screen up here yet? Is anybody still copying some of that down? Or have a question? Anything? Okay. Well, then let's just get to doing a problem. Let's find all the relative extrema. So our function that we're going to use is x cubed minus 3x squared. And immediately I would have you guys find the derivative, because that's where things happen, right? So our derivative is 3x squared minus 6x. And then we got to figure out what to do from here. So I kind of just talked about how critical numbers are where it changes from increasing to decreasing, or decreasing to increasing. It's basically where something happens in the graph. And relative extrema, coincidentally, are tied together with where something happens in the graph. So relative extrema come from critical numbers. Now, the important fact that you're going to find eventually is every critical number is not going to be a relative extrema. Like, a critical number doesn't have to be a max or min, but the opposite is true. Every relative extrema has to come from a critical number. And so that's why our first goal is always going to be to find critical numbers. And from yesterday, critical numbers are where your derivative is equal to 0 or undefined. Who should we go with? Emma? Emma, could you tell me why there are no undefined critical numbers in this one? Do you remember the kind of key thing to look for? That's okay. That's okay. Should I just ask it for anybody? Does anybody remember what to look for to find undefined values in the derivative? And this one doesn't have it? Yep. Yeah, you both. Yeah, I think you both pretty much said it at the same time. That's the downside to electronically asking, huh? But that was perfect. Both of you were right. So really the only way you can have undefined is divided by 0. You could technically have others, like you could have square root of a negative or something like that. But divided by 0 is virtually all of them. And this one doesn't have a fraction. It's not rational, so you can't have them. So we will look for where it is equal to 0. And this is going to be a pretty common method where we have to factor. So let's take out 3x. And you'd be left with x to the first minus 2. And so we end up finding two critical numbers. Joe? Joe, do you remember what the difference between a critical number and a critical point was? Perfect. Perfect. Jack. Jack, how do I find the critical point? Yes. Yes, perfect. Okay, so when I found x equals 0 as a critical number, I'm going to put 0 into the original function, so f of 0, which is 0. And then I'm going to put 2 into the original function, and I'm going to get, what is that, 8 minus 12? So negative 4? Did I do that right? Yep. Okay, so we ended up finding a critical point at 0, 0. You know, texting an emoji has ruined part of math for me forever. Because every time I write 0, 0, all I see is a face now. Okay, these critical points will be needed because if we are asked to find relative extrema, it usually is asking you to find actual points. So I went and found the points right away because I know I'm going to need to find the actual points. Okay, here's how we're going to do this. So a relative max requires that our graph changes from increasing to decreasing. A relative min requires that our graph changes from decreasing to increasing. So we have to figure out where our graph is going up and down. The easiest way that I've found to do this over the years is to make a number line. Some people don't like number lines, and some people like tables. It doesn't matter. On the AP test, they do why did you write positive 4? I wrote positive 4 because I forgot the negative symbol. Good catch. That would have been kind of a big deal. You'll find that when I try to teach and I'm focused on talking and try to explain things, that it's really easy for me to write things wrong. I'm just not a good multitasker, apparently. So I usually try to write a number line just because for me it's easier to visualize. And on the number line, I will write the two critical numbers. And the whole reason I'm doing that is because my critical numbers break up where my graph goes from increasing to decreasing to increasing. It's the critical numbers tell where your graph changes direction. Now, what I'm guaranteed is this whole section from negative infinity to 0, so that's interval notation, that whole section is either going to be increasing or decreasing. It's all going to be the same because the critical numbers tell you where it changes, so that would kind of imply or mean that all of it has to be similar. And then I'm going to have a whole middle section that's the same from 0 to 2. And a whole third section from 2 to infinity. Now, the number of critical numbers you have determines how many sections there are. I mean, that's pretty much it. I don't know if I want to call on somebody or if... This isn't a hard question, but it might be hard for you to put together yet. Mandy? Mandy, can you think of how I could figure out if... let's just pick the middle sections, probably because it's the easiest numbers. Could you think of a way I could figure out if this is increasing or decreasing? Perfect. So if I find the slope at any random spot, that'll tell me if the slope is positive, which would be increasing, or negative or decreasing. So this is called the first derivative test. And this is where I kind of deviate a little bit from Khan Academy because the order that they show things isn't going to be exactly how I like to show it. The first derivative test uses the first derivative to figure out if it's increasing or decreasing. This will imply, and we will get there soon, that there will be a second derivative test. So I pick a test point from 0 to 2. let's just pick one. That seems like an easy choice. And I'm going to test it in the first derivative. Now, I technically don't care what the answer is. I only care if it's positive or negative. You're going to have some easy equations that are, easy to find the answer to, and you're going to have some difficult ones. And as long as you can figure out if it's positive or negative, that's all we care. So if I were to plug 1 into the first derivative, I'd get 3 minus 6, which is negative 3, which means this is a negative slope, which would mean this section is decreasing. It's not lined up, and that's going to bother me. Oh, what the heck? I can't do anything. There we go. Questions on that? Kind of about anything we're approaching or doing so far. Okay. I'm going to put some negative signs up here to signify that that section is decreasing. Okay, then I basically just need to test every section. Absolutely annoying part of this problem? Yes. But I need to test every section. You traditionally pick the easiest number you can. Sometimes a number like 10 or 5 might be easier. You just pick whatever. If I put negative 1 in, I would get 3 plus 6, which is 9. This is a positive answer. So I don't actually have to write this positive slope and increasing stuff. This I'm just putting here for your sake for notes. And then 3, I should have done 10. 10 is definitely easier. Because when you don't have a calculator, 10 works nice. 300 minus 60 would be 240. Positive. Okay. Now, our whole goal was to find maximums and minimums. X equals 0. Before it was positive, increasing. After it is negative, decreasing. So x equals 0 went from increasing to decreasing. And by our definitions, increasing to decreasing would mean a relative max. Why am I having is it A or E? I think A. I need some grammar people here. Is that right? Uh-oh. Are you guys that bad too? Kayla, how did I know the relative max was at 0, 0? Oh, that's true. How did I know it was 0, 0 instead of just x equals 0? Okay, good. That's really what I was looking for. So I needed the actual point, which I had found over here. And it doesn't matter when you find the point. So, like if you start off by just finding critical numbers, you can find the point afterwards. Like it really doesn't matter when you do it. And when I look at x equals 2 went from decreasing to increasing. That would be decreasing to increasing is a relative min. and that was at the point 2, -4. Now, this example had one of each. There is no requirement or set anything on how many relative maxes you're going to have or relative mins you're going to have. We can have none of them total. We could have multiple relative maxes. We could have multiple relative mins. It just, whatever you have is what you have. There is no requirement on a number of them. Oh, I didn't have room to write it, but sometimes it might help you to make a sketch. Like, my graph went from positive slopes to flat, to negative slopes, to flat, to positive slopes. That's what I kind of found through my testings. And so if you want to make a super rough sketch, that can help you figure out maxes and mins. Yes. So we don't do anything with the height of the point until you give the final answer. Everything is about just the x-axis to start with, like going left to right. Yes. Is that what you're asking? Okay. No, go ahead. So you're basically saying from the start, like putting these 2 points on here? So how do you know whether it's coming from the bottom or the top, or like, how do you know what's happening around the points? I mean, I guess that's part of it. So like, oh, go ahead. Oh, no, it doesn't. I got you. That was a good question. Got you. So critical points is where switching directions happens, if it does. Like if we look at like x cubed goes up, goes flat, goes up. So it actually doesn't switch directions. It just like stops increasing and then increases again. So you definitely can kind of get whatever from graphs. Our critical numbers, we just check to see if it does alternate directions. It definitely doesn't have to. I would say most of the questions you're going to get do, because you're kind of chosen equations that, the slope. So I found the slope by putting in a test number. So like from 0 to 2, I picked an easy number, which was 1. And then that's an eraser. By plugging 1 into the derivative, that's how I find the slope. Mm-hmm. Yes. Yes. Oh, I don't know. If you did, that's great. Yeah, so I'm going to guess all the pre-calc classes didn't, but if they did, that's good. That's definitely kind of leading you to this. Theoretically, everything in pre-calc is to help you get ready for calc. You know, I mean, that's by the name. Yeah, and we're definitely going to be doing more with this. This is just kind of the start. How do you guys feel about this? Should I move on to another example? really the big part for you guys to get is why we're laying out all this information, like what we're looking at. Because if you can understand what you're trying to do, like you don't have to write a number line like this. You can write your work however you want. Like this is just an organized way of using information to help you find answers. Okay. What time is it? Noon. Yeah, all right. We'll do this one. Do you guys feel like you could somewhat try it on your own? By kind of mimicking the process of the last one? Why don't you do that? See how much of it you can do on your own. And obviously, if you get stuck, we're going to do it together. But given the fact that we have these super short class sessions now, it'd probably be helpful for you to try as much on your own as you can to start with. So, I don't know, 5-ish minutes. Let's do 5 minutes and see how it goes. I'll put myself on mute and give you guys a chance to think peacefully. It is shocking how long 5 minutes feels sitting there staring at a computer compared to being in a classroom. Okay, so first thing you have to do, figure out critical numbers, because they kind of guide all of this. So critical numbers, this one is similar to the last one where it's factoring, there's no undefineds. Really the difference is that this one started as a fourth powered function, so it could have more curves. 12x squared equals 0. Factor out 12x squared, leave with x minus 1. And so we end up getting two critical numbers again, which is not like standard, it's just, each one's different. So you get 0 and 1. And these are critical numbers. If I want their points, I'm going to plug them in the original function. 0. 1. That's a good thing they're easy numbers. 3 minus 4 would be negative 1. So I've got my critical numbers and critical points. If you want to label them, you can, like if it helps you. Critical numbers, critical points. All right. Once you find critical numbers, then you need to kind of set up an organizer to find information. Now on the last one, I showed you guys the number line method. Honestly, it's usually the one I like to use because to me it's easier for me to visualize it. But I will show you the method that kind of AP they recommend, and it's a table form. So it's not better or worse. It's different. So if I write my information into a table, x equals 0 and x equals 1 still guide everything. But instead, what I'm going to do is my table is going to have a column or a box for my first interval. I'm going to have a column or box for my second interval, and a column or box for my third interval. And I'm kind of showing you the different methods because if you like one better than the other, use it. Okay, so my first section is the intervals. The second piece, and you can label it if you want. My second section in the box is going to be for my test numbers. So I need to test a number from negative infinity to 0. So I would test negative 1. And negative 1 would give me an answer of negative 12 minus 12, so negative 24. This is a decreasing section. I need to test a number between 0 and 1, which is kind of garbage. So obviously a half. I don't know if that's the easiest. 12 times 1/8 would be 12/8 or 1.5. Minus 12 times 1/4 would be 3. So 1.5 minus 3 would be negative 1.5. This is also a decreasing section. Okay, 1 to infinity. I'm going to test, I'll test 10. Why not? Testing 10 would give me 12,000. 12,000 minus 1,200 would be a positive answer, like really big. So that would be increasing. Okay, good. Now, according to this, our graph goes down, flat, up. Well, I know I'm going to have relative min here. So I like to make these little sketches to help me visualize it. You don't need to. I do know that at x equals 0, it goes from decreasing to decreasing. So it's nothing. It's not a max or a min. I know at x equals 1, it goes from decreasing to increasing. And that's going to be the definition of a relative min. So I'm going to have a relative min at the point 1, negative 1. And if our goal was to find any and all relative extrema, that would be the relative extrema. Oh. Sorry. The downside to have you guys on that waiting room is if for whatever reason, if you drop out, apparently you have to be readmitted. How did this one go for you? Were you able to find out that relative max or min on your own? Or was there parts you got stuck on that you want me to explain a little bit more? And or, from your own personal opinion, do you find the table easier or the number line easier? Like, is there one that you prefer? Because I can do whatever. Okay. So, as an FYI, the box method is kind of allowed as work on free response questions, but the table method's not. So it's kind of weird how it goes. But I also haven't seen a first derivative test or a second derivative test in a free response question for a while. Okay. Mainly, I just want you guys to be comfortable looking at either version, because we'll have to use this table method later on. But I think what I'll do is I'll try to use the number line until you get good at it, and then start switching it over. All right. Any questions on this one then? Go ahead. The table is the only allowed method on free response questions. This is not. No idea why. Now, it doesn't completely matter, because when you have a free response question, you have to explain things in words anyway. So it doesn't really matter so much. I've usually just found that the number line is easier for people to understand at first, just because you're used to number lines and you're used to organizing that way. Okay, then let me go to a harder question. And here's what I'll do for this one. Just find critical numbers. Just find critical numbers. Try this on your own. Because once you get good at finding critical numbers, the first derivative test actually is not that bad. Like, you just plug numbers in. But the critical numbers is usually the hardest part for most to get down. Um, Dylan, what do you think? Do you think you could help me start this one? Okay, okay. Let's see. Who should I go? Why don't you pick the next person then? Okay, sounds good. All right, Milan, how do I find the derivative of this again? Do you remember how to do derivative of a fraction or a rational expression? Whoa, what the heck is that? Oh, where'd Milan go? Never mind. He's not going to be able to answer if he's not here. Okay, let's, Haley? Do you remember how to do derivative of a rational expression? We could. So, yeah. So the way it's currently written, we'd have to use the quotient rule. If you wanted to rewrite the equation, you could write the equation as x to the fourth plus 1 times x to the negative 2, and then you could do the product rule on that. And I know I've seen some people do that over the years. We'll just leave it as quotient rule, but just to practice it, but you could rewrite it as product. So quotient rule is g f prime minus f g prime all over g squared. Keenan, what's going to be the hardest part of working with this equation? Do you remember what we have to do with the derivative? Like what are we, when you find critical numbers? Yeah. Yep. So the undefined part will be pretty easy on the bottom. But trying to figure out when the top is equal to 0, the way it's written right now, it's kind of difficult. So what you traditionally are going to have to do with quotient rule is simplify it down as much as you can. So really the only way I can do this, I could technically factor out something in common, but I don't even see that helping yet. I'm just going to multiply it out because I see a lot of monomial terms. So this first one turns into 4x to the fifth minus 2x to the fifth minus, because that minus gets distributed out, 2x. Now this actually doesn't look too bad because I can even simplify that further. So 4x to the fifth minus 2x to the fifth would be 2x to the fifth minus 2x over x to the fourth. The top equal to 0 and the bottom equal to 0 are going to be our critical numbers. Now, I could actually theoretically simplify this further now that I'm looking at it. And I don't know if that's going to help or not, or if it's going to matter. But I probably will just keep simplifying to make it easier for you. So I can see that I can pull an x out of everything, and I can cancel an x from top to bottom. So that would be a 4, that'd be nothing, this would be a 3. So my numerator, I'm going to have 2x to the fourth minus 2 equal to 0. On my denominator, I'm going to have x to the third equal to 0. Well, that's obviously 0, critical number. 2 times x to the 4th minus 1 equals 0. I've got a couple choices here. Because this is simple, I could just add 1. Oh, well. I could just add 1 and then take the 4th root. Or I could factor this into x squared plus 1, x squared minus 1. Either way, this is nothing. This gives me plus and minus 1. So no matter how you solve it, it has 2 imaginary answers, 2 real answers. And then x equals 0. If I go look at the original function, do you guys remember what happens when your original function has a denominator? What is that x squared going to cause? Does anybody remember what it's called? Close. So a whole is when, a whole is when you have a factor cancel from top and bottom. If you have a factor on the denominator, this is going to be a vertical asymptote. So this is what I was trying to tell you when I was trying to say every critical number isn't going to be an extrema. Because we have a critical number that's a vertical asymptote. And it's called a critical number because your graph does change directions before and after it. So it's called a critical number. This is not a critical point, though. Because if you plug it in the original function, you get divided by 0. So it's only a critical number, and it's only going to be used to separate out increasing and decreasing sections. So you can have critical numbers that aren't extrema, but every extrema comes from a critical number. And what you'd find is this plus and minus 1 would be the only places where we could have a max or a min. And I didn't want to finish this problem because time-wise, I knew we wouldn't get the rest of it done. But I thought this was a good example to show you guys that things can happen that make it seem like it's going to be something, but depending on what it starts as, it can't be. Okay, so anyway, this is the whole second topic in the unit. I've actually started kind of talking about when I talked about the first derivative test. That's going to be a different section a little bit later on. So you're welcome to try to work ahead in Khan Academy if you'd like. Otherwise, I wanted to have these 2 major topics down pretty well for you. Critical numbers and relative extrema, because these 2 topics are going to be part of a lot of things in this unit. And so we'll be able to start learning new things at a faster rate probably from here on out. Partially depends on if you're practicing it too. I mean, like you're gonna find that you find all sorts of weird problems, like things happen. So either way, I guess I'm done for today because like I said, I knew we wouldn't be able to finish that problem. I'll be on at 1:15 again if you guys want some help with anything. Otherwise, thank you for coming today. I will see you tomorrow.